Today's lesson is lesson 5.3, in which we talk about polynomials. Now, polynomial in one variable is basically any polynomial that has one variable, and one other thing, the variables cannot be in the denominator of a fraction. Now, once you've got a polynomial, you want to put it in order, what we call descending order. Get the powers going down. So like that's second degree, first degree, go with your highest power first and get them in order. Once they're in order, we can describe the degree and the leading coefficient. The degree is basically the power on the first thing once they're in order. So that's first degree, second degree, third degree. Then the leading coefficient is the number that's in front, 4, 5, and 8. Those will be very important here in just a little bit. Okay, so let's take a look at some examples. State the degree and leading coefficient of this thing. All right, so let's make sure it's in order. I've got 7z to the third minus 4z squared plus z. All right, the degree is third degree. And the leading coefficient is 7. Simple enough, third degree and 7. Let's take a look at my second example. Notice, because I've got two variables showing up here, a's and b's, this is not a polynomial in one variable. So we stop there. And my last example, you'll notice on this one, the powers on the x's are not in order. Rewrite this to where they are in order. Be sure the sign stays with the term. That's negative 8x to the 6th plus 3x to the 5th plus 2x squared minus 4. Alrighty, my degree is 6th degree, and my leading coefficient is negative 8. Simple stuff. Okay, now the next thing on your worksheet, you're basically evaluating these functions for the given values. So all you're going to do is you're going to take out, in this case, you're going to take out x and you're going to put in a negative 1. So remove x and substitute in the negative 1. Doing so, follow your order of operations. Please excuse my dear Aunt Sally. So let's multiply first. That's going to be 4. Negative 3 times negative 1 is a positive 3. And now we'll just add those together and you're done. Now you got 2 here. So now we want to figure out what p of 2 is. All right, so once again, you're going to take out the x and you're going to replace it with a 2. So that's 4 minus 3 times 2. And just follow your order of operations on this. Okay, multiply first, and then carry through on the addition or subtraction, and you're done. All right, number 8 similar. I'm not going to do that one. Let's take a look at this one. I want to look at number 14. Okay, in this case, we're going to replace x. Now, also, this is function r, so we'll be using the r function. This one, you would use the p function. Now, on this one, we're going to replace our x, not with a number, but with a term right here. That's going to be 2a. So r of 2a is equal to 1 plus 3. I'm just writing this down. Now take out the x and put in a 2a. Now simplify this expression. 1 plus 3 times 2a is 6a. That one's finished. Okay, our next objective, this is the biggie here. What the degree from our first part of the lesson talks about is just like, these are degree problems. This is what a 0 degree problem looks like. It's a constant function. This is a first degree, second degree, third degree, fourth degree, and fifth degree. All right. Now, so what we're looking at this is the degree describes the maximum number of times that this thing could cross the x-axis. This thing's going to cross once. This one's going to cross twice. Now, it may be a function that does this, and it's not going to cross at all. That's why they say the maximum number of times. This.
All those who are testing this morning should be released to go back to their testing sites at this time. Again, all those who are testing this
Welcome to my world.
should be released to go back to their testing
Announcements.
sites at this time.
Right back to it now. Thank you. Okay, so this one doesn't cross any, but that one crosses twice. This is third degree, so it could cross as many as 3 times. This is fourth degree. It could have up to 4 roots, and this is fifth degree. And then the last thing we talk about is the end behavior. The end behavior basically talks about what's going on at the ends here. So for example, this one, as x is decreasing, that's all this means, x is decreasing, y, or f of x, is increasing. You see, that's what that means, it's increasing. And then on the other end, so that describes this end, on the other end, as x is increasing, that's what this means, y is increasing. That's this one right there. Okay, so this would be what an even function looks like. Now, it may do some other things, and it may go and just do stuff like this, you know, it may look like a W or whatever. But overall, it's either going to start high and end high, or it's going to start low and end low. What tells you whether it's going to start high and end high, or this one, is the leading coefficient. If it's positive, it's going to do this. If it's negative, it's going to do this. Okay? Odd functions, think of lines and think of slopes. All right? A leading coefficient being positive would be like a positive slope. It's going to start low and end high. Or if it's a negative leading coefficient, it's going to start high and end low. Now let's take a look at our end behavior on this one. Okay, we're going to start over here as x is decreasing. That's this one right here. Notice, as x is decreasing, y is decreasing also. That's what that means. As x is increasing, y is increasing. So this will tell you basically about the end behavior of polynomial functions. It will help you to solve problems. So let's take a look at this example. First thing, let's get our template set up. We're going to say f of x, and this symbol means approaches. I'm going to leave that blank for a second, as x approaches negative infinity. That means that we're talking about going this direction right here. So, is y going up or down? It's going down, so I say negative infinity. Now let's take a look at this end, right here. F of x approaches. Now look over here. We're going down, so that's approaching negative infinity also, as x approaches. Now x is increasing, so that would be positive infinity. If I determine whether it represents an odd or an even degree function, this one would be an even degree function because it starts low and ends low. So that's even. And state the number of real zeros. We're looking for where it crosses the x-axis. This one does not cross the x-axis, so it's none. Let's look at the next example. All right, let's describe the end behavior. Let's look over here at the left side. F of x approaches. Okay, notice how y's value is decreasing. That would be negative infinity. And since this is on the left side, we'll say as x approaches negative infinity. Now let's go to the right side. Notice how the values of y are increasing on this one. It's going up. So that's approaching positive infinity as x is increasing also, approaches positive infinity. Okay, next, determine whether it's even or odd. This one would be an odd degree because it's gonna, it starts low and ends high. That's odd. And last but not least, state the number of real zeros. This crosses one place, so it has one real zero. That is the end of the lesson for today. I hope you enjoyed.